Welcome to our notes on more angles and intro to the dot product. Students will be able to calculate the angle between two vectors by applying the dot product and magnitude. Students will be able to explain verbally and in writing a process for finding the angle between two vectors. Part 1. Mark up the definitions and formulas and then attempt the algebraic box. The dot product of two vectors u and v is the following. U dot v is the horizontal component of u times the horizontal component of v plus the vertical component of u times the vertical component of v. This will result in a scalar, not another vector. If theta is the angle between two non-zero vectors u and v, then the cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. So if we solve for theta, then that means I need the inverse cosine of u dot v divided by the magnitude of u times the magnitude of v. The algebraic box says find the angle between vectors u and v. So here I have the linear combinations of the vectors u and v. So I'm just going to zoom in a little bit. Remember, this is going to be u1, u2. This is going to be v1, v2. So I need to first find u dot v, which is going to be u1 times v1 plus u2 times v2. So u1 is 6, v1 is 5, and then u2 is 8, v2 is 12. So 6 times 5 is 30, 8 times 12 is 96, and 30 plus 96 is 126. So now I'm going to find the magnitude of u, and the magnitude of u can be found as follows. If you think about either the Pythagorean theorem or the distance formula, they both stem from the same principles. Then I'm going to need my horizontal component squared plus my vertical component squared and the square root of that. So I'm going to find the square root of 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10. Now let's find the magnitude of vector v. Very similarly, I'm going to have v1 squared plus v2 squared. v1 is 5. Let me make that a little bit better. 5 squared plus v2, which is 12 squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. The square root of 169 is 13. Now that I have all of these, I'm going to now find the angle using the dot product. So theta equals inverse cosine of u dot v divided by the magnitude of u times the magnitude of v. So I'm going to plug everything in. So inverse cosine of 126 divided by 10 times 13. When I plug this into my calculator, I get approximately 14.250 degrees. So suppose you forgot how to find the angle between two vectors using the dot product. We can always go back and calculate this old school by first drawing both vectors in the coordinate plane, dropping a perpendicular. Well, we don't need to, but I will just for visual purposes. If I drop a perpendicular here, it's like I have a right triangle now. And so then this angle right here would be what I would call theta 1. And this bigger one, if I were to drop a perpendicular here, this bigger one would be theta 2. So how would I find theta 1 and theta 2 based on knowing the vector and where it is? Well, I use the horizontal and vertical components. So for this one, I know it's going to get a little crazy here, but U1 in this case is 6. So U1 equals 6. I'm writing it down here. And then U2 equals 8. So what I would do to find theta 1 is to use inverse tangent of U2 divided by U1. In this case, I would find inverse tangent of 8 divided by 6. Okay, for right now, I won't even bother like labeling the red one, but very similarly, theta 2 is going to be inverse tangent of V2 divided by V1. So that would be inverse tangent of 12 divided by 5. I'll use a different color here. The angle I'm looking for is in here. So the actual thing I'm looking for is going to be equal to my theta 2 minus my theta 1. So I could just go theta equals the inverse tangent of 12 divided by 5 minus the inverse tangent of 8 divided by 6, and I will in fact get the same answer of 14.250 degrees. Part 2. Other properties of the dot product. So below I list a bunch of properties of the dot product. I want you to try to figure out what they mean or where they come from or something like that. So what do the following properties mean in words or using some mathematical proofs or something like that to figure out where they come from? I'll do a few of these and then I'll have you do the rest. Number 1, I see u dot v equals v dot u. What does it mean? So before I write down what it means in words, I want to kind of figure out, well, why is this the case? So u dot v, remember, is going to be u1 v1 plus u2 v2. And if that's the case, then v dot u is going to be v1 u1 plus v2 u2. Well, what do you know about multiplication of numbers? We learned the commutative property of multiplication. This means A times B equals B times A. We've learned that, and that's what we see here. Well, I can rearrange U1 V1 to be V1 U1. So, since U1, oops, that should look like a U, not a V. U1 V1 equals V1 U1, and U2 V2 equals V2 U2, then that means the commutative property of multiplication applies to the dot product of two vectors. I know this is like really fancy, and it's because, you know, I've studied this before and I've put some stuff together, but try to think about why it might be equivalent. Think about where it comes from. So you can show the mathematical proofs. If you need to, you can use a combination of words. You can say what it means. Whatever you need to in order to study these properties. Here, I'll do one more with you. Here's number 5. It says two vectors are perpendicular if u dot v equals 0. Well, let's think about what perpendicular means. Perpendicular means 90 degrees, right? So two vectors, so vector u and vector v will have a 90-degree angle between them if u dot v equals 0. Well, why is that, by the way? So if I use the formula for finding the angle between two vectors, then remember I have u dot v divided by the magnitude of u times the magnitude of v. Well, if I'm saying that the dot product is going to be 0, then that means 0 will be inside of the parentheses. Well, what is the inverse cosine of 0? It happens to be 90 degrees, and so that's why it works. So for the remainder of these, I want you to go through and I want you to try to make sense of all of them. Either use words, um, proofs, or anything you need to in order to figure out what is this saying.